This is Paolo speaking. I will start with the installation, the technical part of the installation of the Reios IoT platform. But before to start, I would like to summarize the information that you received yesterday from my colleague. And then I write down this slide where you can see the tracking architecture. The focus is tracking. So we have a different level. Starting from the bottom, we have the IoT device layer, where you can see there are different type of tags. We have people tags, wearable tag, we have asset tag, QStat, this is the Rajant Health wearable, but we can also collect information from generic smartphone and any other Bluetooth BLE devices. The keyword for this layer is RSSI. RSSI, that is the received signal strength indicator, is the measurement of the power level of a received signal. And using Bluetooth RSSI on the access layer, we have gateways that convert Bluetooth to Wi-Fi. The key goal of the gateway is collect information from BLE devices and make the RSSI measurement. So the BLE device have a common behavior, that is send any type of beacon. And based on this beacon, the access layer, the gateways, get the information from the Bluetooth signaling and save the RSSI power level. As you can see at the access level, there are three different type of devices. All of them are Reios devices. We have gateways named as gate. There are that are standard gateway converting BLE via versus Wi-Fi, but we also have gateway that have signaling information in addition, that are squares, and also desk gateway. The last two gateways are signaling LED strip that can change color, and with that color we can also add information of the gateway. On top of the access layer, we have the transport layer. The transport layer is whatever Wi-Fi network. We can deploy our own Reios network, the Rajant breadcrumb network, but you can also use the customer, the legacy network that is already in place. The purpose of the transport layer is to collect the gateway information from the Wi-Fi and send information to the processing and application server. So on top of the transport, there is the service layer, also called the application or processing layer, that receives the information from the access network and send information to the service server. Our server, called Edge server, contain all the services or the application that can handle the RSSI information collected from the gateway. Based on that, the application can process and calculate the position of the device. At this layer, as you can see, usually there is a local network. There is a switch in which all the server is connected, and how to get the information, the tracking information in the server, you can access via a local client that is a front end, whatever device that you want to use, that can access to the presentation layer of the server in order to get the display of the tracking information. But usually the local network is already connected to the World Wide Web. So same information, same presentation layer can be accessible via, on the left, a client connected via the VPN. This is the architecture, the base architecture that you have to keep in mind, and based on this, today we will describe how to install all the service application that run on our Edge server. Then we also discuss how to provide a VPN configuration. VPN is not mandatory, as you can see, because customer can access locally, for sure, because it is inside the local network. But it's very useful for the deployment configuration, the first deployment phase of the system. So typically, based on our experience, every Reios OT tracking deployment has its own VPN. We can provide a VPN from our own architecture, but also you can use, if already in place, a VPN that the customer has available and can share to you. Okay, so we can go on with the So the first part of the training today is explaining how to set up the Edge server with the Docker engine installed. Starting from the beginning, our application were deployed by itself. I mean, we install on the server by scratch, and we set up a database application, the broker and QTT application, and all other Reios application. But this procedure is a very tough work because it take time. So we move to the Docker framework. The Docker framework is an open source platform that help you to facilitate your deployment and also the management of your application. there are container. Container is just a keyword that Docker use for the standard service, standard application. But the containers is also is not only your piece of software, but is also all the operating, let's call operating system that you need to run your application, your piece of software in different environment. And it's very easy in this way to deploy a package, and with that single package, you can install the package on Linux, on Windows, for example, so you don't care about the destination. The requirement is only to have a Docker framework running on the machine you want to install. Some keyword for the Docker framework. We talk about container. Is an executable package, is an application that include everything to run. So not only your deployed code, but also library and also configuration files. We have also images that are template, let's call it template, that you use to create a container. We have a Docker file. Is just a configuration file that contain command to build an image. And we have a repository where these built images are saved in order to facilitate the deployment, because on the deployment side, you just get the images from the repository. So you just need a URL to get the image. And we also have a Docker Compose. A Docker Compose is a YAML file that contain information to run different container, and it's useful to collect multi-container Docker application in a single description file. Next. Okay, sorry. Advantages or benefits. You already talked about portability. Same deploy on different operating system. Efficiency, because there is a minimum overhead. The framework is very light, so it's much more light than a virtual machine, for example. And last but not least, flexibility, because it's very easy to build, to test, and again, simplify application deployment. Deployment is a critical phase, I think, for every environment, but in particular for IoT, when the number of devices is met, is very difficult. So having a framework that help you to simplify this phase is very, very important. Is that the main reason, because we move to the single application deployment in a Docker environment. Okay, so we talked about a container. These are our container. These are our application. On the left, again, we can start just to summarize that we have a BLE tags sending beacon on BLE. BLE beacon is collected from gateways that get the RSSI measurement, and this gateway via a transport Wi-Fi network send the information to the edge server. The main container, the main application that we have inside the edge server in the Docker environment are the broker MQTT, because all the information sent via TCP/IP are on the application layer MQTT. We have the main database is a container database in MySQL database that run different database schema that are the schema that each our application service use. Then we have the telemetry application. The telemetry is the main processing layer app that get the RSSI and apply all the telemetrization rule and get the position of the device. Then we have a module service for the configuration and also for maintenance. We have an event manager. At the moment, is not involved in the tracking, because the focus of this presentation is tracking. So events are not involved in the tracking, but is and also is just an example of the solution is modular solution. So you can add the services, and the event services is one that the Reios IoT platform can provide. And on top of this, we have the presentation layer that get the information from the database and allow the external client to connect in order to get a typical web interface to have the information from the Reios tracking solution. Okay. Server requirements. Hardware is 64-bit CPU, 4 or 8 core is sufficient. Minimum 8 recommended 8 GB of RAM. Storage 200 GB. And okay, at least one Ethernet port for networking connection. Operating system, we can deploy our solution on Linux. Usually we use a server Ubuntu, or we can also deploy on Windows. On Windows, the requirement is to install the Windows subsystem for Linux 2, because it's a mandatory component to run the Docker engine. And our experience, we can deploy the solution on different environments, direct on the physical box, the physical direct installation, or we can have a virtual machine, VirtualBox, VMware, or also on the cloud. Okay, in this slide I summarize the command to install Docker engine on a Linux Ubuntu. So as you can see, it's very simple, because there is just a very short list of commands you have to run. You have just to allow the specific repository and to install the Docker Community Edition from that repository. It's an open source application that you can install without any license. Then you can have an example of the command that you have to run if you want to check the installation status. And that's all for the Linux. On Windows, instead, there is an application called Docker Desktop. And but before to install Docker Desktop on Windows machine, you have to install the Windows subsystem for Linux. And to do that, it's simple. You just run the command Windows subsystem Linux minimum install, and restart the PC. After that, on Linux, you can download from the installer of the Docker Desktop application. You have to go to the Docker Desktop download page, and once downloaded, you just double click on the installer. Then you have to follow the instruction on the installation wizard. You have to click yes when the installation wizard asks you to use WSL2, and that's all. Then you can have the Docker Desktop installer as a standard Windows app, and you can run the Docker Desktop as a standard application. Okay, Docker Desktop allow you to sign in. That's because we talk about repository. The repository is the cloud where we saved our images. So it's important that the Docker Desktop that run the Reios OT platform is bound to the Reios repository. So you just click on sign in. You have to enter the Reios username and password. And after that, you can see that on the bottom right, there is a Reios account that is signed. In this slide, I show you how the Docker Reios repository is also accessible via the browser. So you can open your browser and point to hub.docker.com as using the same credential, Reios and Reios password. You can access to the Docker Hub repository. And as you can see from this screenshot, there is the Reios folder where we saved our images, our application. For example, you can see the telemetry, the configuration and maintainer, and all the other applications that we install in our Reios IoT platform. There's the detail of the Reios Web Manager front end. As you can see, you can have the list of the different deployment. It's very easy using the Docker infrastructure to create images that have a specific tag, is a label that you can set up. You can define when you are building an image, an application, and it's useful to define the version. For example, you can have a different release or also different version for different client. And on the same repository, you can save all these different images, and I can show you later from the configuration file of that specific customer, you can get the tag that you need. Okay, that's the end of the first part of the presentation. I can go on, or if you have any question, I wait for your question. Go back to the
Is the recording available to us after the training session?
Yes, this training session is recorded.
Yes, we will send you also the recording. We'll make it available.
Thank you.
You're welcome.
Okay, stop sharing and try to open the next one. The next one is the VPN, this one. Okay, share again. Okay, VPN. Okay, this is my favorite slide. So the architecture, we talk about the VPN. It's not a mandatory feature, but is not mandatory for the end user, because the end user, the customer, can access the tracking information on your local network. So can use the local client to access a server representation layer. But not only for maintenance, but mainly for the first deployment, the commissioning phase of the solution, is important. It's very useful to access to the customers, to the client environment using a VPN, because it's easy for easy access remotely. So you can use a VPN client that the customer already have available. Let's suppose the customer, most of them have open VPN server, 40 client, 5. So is already available. They provide to you just a client credential in order to get in. In case this is not available, our suggestion is to use zero tier. Zero tier is a VPN solution that it's almost simple to handle and to deploy. The advantage that we have different zero tier client for different devices, and so this the VPN service that we use. You have to go to the zero tier server, open the browser to myzerotier.com, and you have to sign up first using your own email, and you can define your own credential. After that, as you can see on the right, you have to log in using the credential you have to sign up before, and once login, you can create your own network. Each network has a network identifier, so you can create different network, each with a specific ID that will automatically provided by the zero tier service. And for example, you can have one zero tier network ID for each customer. Once you create it, you can go inside the network ID configuration. If you go to the settings section, you can define an alias for the network ID. You can define, for example, this is the name we use for Reios _ZT, and you have define the access control, the type of the VPN you want to set up. You have the private and the public. Using the private, the client has to a client to access in has to know the network ID for sure, but also need to be authorized from the VPN manager. In the public, instead, the client has to know just the network identifier. After that, you have to go to in the advanced settings and define the managed route, that is the network, the IP network that you want to assign to that specific virtual LAN. Let's assume we use the /16 IP space address, but you can define whatever network scope you need. So this is from the server side. From the client side, as you can see on the splash screen of the zero-tier page, you can have different zero-tier client for different platforms, not only macOS, but also Android, Windows, macOS, Linux, also on Raspberry, so different solution you can install to have the client for different platform. So you just go to the download page and select your application client you need. You have to download the client and install. This is the example for a standard Windows PC. Once installed the application on your PC, you have to open the application and join to a network. To join the network, you have to insert in the join form the network identifier that you have created for that. Join to confirm. Okay, the first answer after you join to the network is your access is denied. Access denied because the type of the VPN is private, so you have to be authorized by the network manager, just the VPN manager. So your client should show access denied. In this way, you can talk to the network unless you will authorize. In order to authorize, the VPN manager has to log in to the zero-tier dashboard with the created credential and go to the section members. There is a member section that display all the clients that are asking to connect to the VPN. So for each client, a new client is not enabled by default, so you have to enable the client. You have to click the checkbox. You have to add the address for the specific client, and you have to click the authorization checkbox. After that, the client will be authorized. As you can see on the right screenshot, there are blue row that is different different client authorized inside this VPN. And I don't know if you see here, the status on client side is changed to access denied to OK. And that's okay. Remember that in order to connect the client and the server, not only the client has to be authorized, but also the server. So this is a mandatory operation that you have to execute. That is assign a specific address to the edge server. That's because this address is the VPN address that each client has to know in order to get into the edge server, to our Reios IoT platform server. What else? No, just to say that it's important to have I think we use a naming convention that is standard, that is once defined the IP network, the server is the last IP available for the network, but that is up to you. It's important that to define an IP for the server, and keep in mind that TCP is important because it is the reference point for each client to accessing, and also to the server can be assigned a name, to be clear that on the dashboard there is one of the members that is the edge server. Okay, and this is the VPN part. Waiting for your question if you have. If not, I can go on with the installation. Where is the no, not this one. Is it platform installation? Okay, share again. It's coming. Oh, okay. Oops. So we talk about Reios IoT platform first installation. We are talking about the part of the Docker image that has to be installed on the edge server. To do that, Reios provide a package that you can download from a Reios repository. And as you can see from the left screenshot, there is an example for the demo kit, for example. But in our repository, we have a different folder for different customers, for different environment. You have to just click on the link and download the tar file. You have to unzip the tar file in your C folder. Okay, this is the example for using the Windows machine, but it's the same for the Linux, because as you know now that the platform is runnable both on Linux and on Windows. So once you have unzip the tar file, you can see a folder named Reios IoT Platform, whatever, this is the name of your installation, containing 5 folder and the Docker Compose file and just a README file. As you can see, there is a SQL init folder. In the SQL init folder, you will find the SQL init file that is imported by the MySQL application at the at the first installation. So at the first installation, the database server get the database schema from this folder. We also have the configuration file from the Nginx. So the Nginx is an Apache equivalent, so a web server that we use. There is also a folder for the MQTT broker, and for this is a Mosquito. In this folder, we have the configuration of the broker. There is a folder containing the firmware, and this is the firmware that we use to deploy to the gateways via over-the-air configuration. And there is a generic configuration folder that contains all the configuration file for each application. And there is also the main file, that is the Docker Compose. As described before, Docker Compose is the configuration Docker reference file that contains all the information to run different Docker applications. This is the example of our Docker Compose YAML file. As you can see on the left, there are the different services that we install in our edge server, starting from the database, backend, presentation layer front end, configuration maintenance, telemetry, and also the event manager. And for example, for each service, you can have information for the image that this service have to download, the port, so the network information, and also the volume link, and also some other configuration parameters specific for that service, for that container. If you see the screenshot on the right, there is the backend service, and you can see here the name is okay, backend, and the image. You remember that on Docker Hub repository, our images are referenced by a tag. So in this case, for this deployment, we want to use 1.7.2 tag. And then there is a main section. This is the environment variable, where you can set different environment variable that are used inside the application. For example, there is the key that is used for accessing to the ArcGIS web cloud where is saved our maps, for example. There is the MQTT and user and password for the MQTT, and everything that is necessary for the running of the application of the container. Okay, so we already installed the Docker Water Desktop. Now, before to run the Reios Docker Compose file, you have to run the Docker Compose, that is the Docker engine that handle all the container in the Windows environment. So you already showed this slide, but it's just to repeat. So you have to run to open the Docker Desktop. You have to sign in with the Reios credential. It's important because it's necessary for the YAML file to have the permission to retrieve the image. It's important so to sign into Reios repository, and after that you have to open a PowerShell on a Windows machine, or also a Windows terminal is the same. You have to move to the Reios platform you have to create before, and then you have to see the Reios platform. As you can see here, you can see the same folder that we showed before using the Explorer windows. So you have to, on the right, run the command that is docker compose app with some parameter, and in this way the docker compose app launch the docker compose YAML file and execute all the container that are in that configuration file described. Before to run the container, if necessary, but is just for the first time, the Docker Compose download the image from the repository, and after downloading, it run the container. So you have to wait a while until you can see the green started information for each container. Again, you should recognize that the list of the container that are listed here is the same that you have in your compose YAML file. Once all the containers are up and running, you can open using your browser, using your local client. You can open the web manager interface using the login, admin, and password. I show here that from the PowerShell, you can see the list of the started container. But also, if you go to the Docker Desktop application, that is in background in this image, on the Docker Desktop application, you can see the same information in the Docker Desktop window. And again, you will find here all the containers that are in running mode, and you can go, for example, if you click on the container name, you can have the container log window, where you can find all the log information that the application write down when it's running. Okay, now we skip this part because we talk about tomorrow. Okay, so for me, the slides are finished. We can I can show you a real environment if you want. If you have any question in the meantime, stop the. What is it? Stop the code. Allora. Okay. No. You have to change desktop. Let me connect to the Windows machine that we have in our lab here. Okay, let's start from the Docker desktop. Okay, this is the, let's start from the PowerShell. As you can see here, we install a Reios platform for a POC that is running in Puerto Bahia. It's just for example, but and as you can see here, you can find all the folder and the file that I showed you before. Let's go in deep, for example, in SQL init. Okay, from the SQL, I show you that for example, there is a database schema that the database server has to install at the bootstrap. So this the schema of the table that the database use, and also with some default value that you have to have on the first part of the installation. We also have a configuration folder, for example. In the configuration, there are, for example, for the telemetry. In the configuration, there are all the configuration files that each application use. For example, from the telemetry. Okay, let's do it the same. There is a configuration file that define, for example, the refresh rate of the tracking application. the minimum of server that the application have to use to calculate the position, the maximum of server, the different prioritization algorithm, and all the parameters that, for example, the MQTT host, the port, keep alive. So all the information of the configuration parameter that the application have to use. And that is just an example of the configuration. And again, there is the main configuration file is the YAML file. You can recognize our application. I would like to add that, for example, in this specific deployment, we do not use BLE tracking, but we use GPS tracker that send information via a LoRa gateway. So the GPS, the tracking information we received is in terms of latitude and longitude. And so we have to, it's very simple for us to deploy. We have deployed an application that simply is inside the Docker desktop YAML file. And this application has in charge the position conversion from latitude, longitude to X and Y that we use for a local position. And that's the example. And as you can see again from the Docker desktop, you can see also the tracker in the list of the containers that are at the moment running. Telemetry, in this case, telemetry is not working. It's just sending a keep alive, but it's not involved in the tracking in the tracking calculation. And we can skip that. But if you go, for example, in the MQTT, in the MQTT GPS tracker, you can see that there is a position conversion from this latitude and the longitude received that timestamp to the local reference position X and Y. That's just an example of the log that you can open using the Docker desktop. Then I can show you, we talk about VPN, also Docker Hub. Oops, no. Is it? Okay, let me show from my PC. It's better. Choose a Reios repository. Our Wi-Fi is not the best of the world. Come on. Okay. Okay. So this is me, because it's a Reios account already login, and here you can have a look of the image that we saved. We produce and save in this repository. As you can see, you can define the image private or public. And for example, if you go, this is the last one we deployed. As described before, there is a different image version. There's also information where you push the image. The image is pushed once created on the factory, on the software factory, and saved for the deployment, and also the information when the image, how many times the image is pulled from for installation for the installation deployment. And that's the Docker Hub I show you. We want to show also not the Git, but the zero-tier dashboard. Okay, login. Okay, this is a specific VPN that we use for the lab, for example. And as you can see in this network, there are one server configured. There is the desktop lab, and there are two clients that can access to the server using this VPN. One is Carrier, and one is it's me. And this also, you also have here the information regarding the client last seen. And that's all. Once a new client is trying to connect, you have to enable the client and authorize it. For example, if I go here, as you can see here, this client is authorized because I can deauthorize the client. I also assign a name to the client. It's not mandatory, but I can also define a specific IP for that client, or delete. And that's all for the zero-tier. Okay, I think that we have to wait because we have to start tomorrow. But just for today, as you can see here, there is a splash screen when you log in the first time to the edge server, and we will see tomorrow how to continue. And no, today Franco show you how to start with the configuration of the site, the first site configuration. Okay, for me it's okay. If you have any question, if not, I think Franco continue with site configuration is the first part of the platform configuration.
Good morning, everybody. My name is Franco Serio. Can you close, Paolo? My name is Franco Serio, and I'm the CTO of Reios. I wanted to show you today how we can customize a site, because what Paolo showed before was how to create a general version of the software. So from the registry, you can download the version, but this is a generic one, is not associated with the site. Now we have to understand how to make possible to create a configuration for the site. Okay. We want to install a system. This system is a generic one, and now I can show you what kind of command you have to give to start the configuration of the site. Accidenti, non mi si muove il mouse.
No, vediamo.
Okay, this is the point where Paolo stopped his presentation, and now we have to say how to create the local configuration. There is, as you can see, a login possible, okay, where the authentication will be required. There are three ways to start. The address to start the system can be a local host, can be a name of a domain, or an IP address. If you use the VPN, for instance, you have to digit here the IP address of the VPN. If you are running your application in a PC or in a server, just in one server, you can use localhost. If is an application running in the cloud, you can provide the name. And so in this case, the platform, we start asking you, sorry, asking you what is necessary to create a site. So there is a wizard that are in 4 points. One is create the site. The second one is create a floor, create a default template, and the optional create a tracking profile. So you are using a wizard. You are able to introduce something that can characterize a customer. So in other words, what you saw before from Paolo was a generic version for any type of customer. If you have 10 customers, you can you use this approach, and you can use the same software and the same tool inside the Docker repository to create a configuration. Now, for each customer, you have to create your own configuration. So you start to create a site. The wizard will present you this panel, and you can go ahead adding the information for create a site. So the wizard allows to create an instance of a new site. A site is georeferenced location where the Reios software can operate. So you have to give the site a name and to provide the geographical coordinates, latitude, longitude, and angle of the map prepared using ArcGIS Professional. As you remember, yesterday, Diego showed you how to create a map. Now we have to reference this map in the site. This is a special map for this site. It's not a generic one. So you have to characterize your site with this type of information. What we have to do is digit the name of the new site, digit the map ID, copy the latitude, longitude, and angle in this way. When you prepare the map, you have this type of information on ArcGIS. It's just enough to make past copy and paste, okay, in order to create the configuration. In this case, after this selection, you can write you can see the map ID, you can see the latitude, you can see the longitude, and you can see in this case is 0 degree because the map that we show here is without the angle, but this is the angle that you have to copy. Okay, after that, you can define the floor. So you have the map, and in the map, you can have multiple floors. Suppose that you wanted to create a building configuration. So you have a map of the building, where the building is, but you can add different type of floor. And each floor can be added here using a digital name of the floor, a digital description of the floor, the digital offset, and you have to copy for this floor the map with the area with all the information. This is an example. So where you have to copy, click and copy and paste the appropriate information. Cacchio, si è arrestato. Sorry. Si vede?
Yes.
Okay, sorry for that. As soon as you have defined all the information about the site and the floor, you can start describing what is the environment that is necessary to set up for this site. And so you can start giving all this type of parameter. I want to explain what kind of information you have to provide here in order to create something that is site dependent and not generic one. The first point is to define where you have the MQTT host. So you have to provide a URL where the MQTT broker is installed. So this will be very important because all the device will send information to this host. So the MQTT client download inside the device gateway, inside the square, inside all the machine that you saw before, need to know what is the host, the MQTT host. Of course, you can define also some important parameter. For instance, what is the keep alive device for the MQTT? So the frequency in second of keep alive message sent by device. This it's an important point because if you lose a device, you want to know immediately that the device is not available for the service, and you want to make all the maintenance activities necessary. So this keep alive frequency, it's important to have the stability of the system. Another important point is where you want to have the repository of the software for the device. The repository for the software means configuration and also the firmware. So you have to define where the device will be collect the information via over OTA, over the air download. The config of the device is done using a JSON. So if you want to see during the maintenance of the system the JSON, you can access and see what is the configuration that used by the device. this configuration is created automatically. No one can touch a config that is very complex, is about 100 lines of information. Another important point is the time, the time zone, because we need for to have the system synchronized, we need to have also all the vessels should be shown in the same way. So we need to know the difference, the side time difference from Greenwich. So if you have the system are based on UTC, but when we show the actual hour, we need to know what is the difference from the UTC hour. Also, the clock of the internal device has to be tuned using an NTP server. So it's important to provide for the side the appropriate NTP server. Should be in Italy one, in Mexico another one, in USA another one. Of course, it's possible to define what is the most performant server. After that you have defined this type of parameter, it's as Paolo showed before, we need to allow the device to speak using a Wi-Fi network. So we need to know what will be the SSI ID of the Wi-Fi network. So it should be a customer client XYZ, should be any type of SSID the customer want to provide. Of course, this SSID is the SSID of the access point. So if you have a network, already existing network, and you wanted to add an access, a new SSID for the IoT, the Reios IoT platform, you can define the new SSID, and you can provide the information in this template, default template configuration, saying the name of the SSID and the password that has to be used. Another important point is the SSID access pointer SSI. So if you have some trouble with the network, you can define that it's possible to switch network if you reach a minimum RSSI. Suppose that you don't want, you have some trouble with one Wi-Fi network, you want to move from one Wi-Fi network to another one when the RSSI of the access point is not good enough. So this allows you to move from one access point to the other without disrupting the server. If the device has the LED to show the LED strip to show the information, it's possible to define the default color, green, for instance, to say all is okay. And also you can create the effect that you want, blink, pulse, or solid. To introduce this parameter, it's very simple. You have a map and where you have a 2-digit, the default template name, the MQTT, and all the information I explained before. When you have finished, you have a message successfully created Reios Office template. Now you have defined the map, and you have defined all the template configuration, the default template. So and you are ready to set up something different that is related to the tracking algorithm. Yesterday we spoke about the possibility to improve the trilateration process, adding a table, a variable table containing RSSI distance map. Now I want to explain you how to do that and how it's possible to download this in the system. Take care that in any case there are already pre-configured table for indoor outdoor when the network is simple. If you have something special, you have a different environment with barrier, with metal equipment, etc., you can define different type of table. The calculation of the stack position is done by each S-gate, determining the distance based on RSSI value. We explained yesterday. Now we can see how to create this. The RSSI can vary depending on the S-gate topology, such as the antenna type and the TX power of the tag. So we have to characterize this. The methodology to create this table is this one. You have to put one device reading the RSSI, one S-gate, let me say, and you put just in front an S-gate, one tag to measure the RSSI. The measure must be done at the first one at 0.5 meter, and you can reference each 10 times. So 0.5, 1 meter, 1.5, etc. for this reference point. Later on, you can move 5 meter step until you receive the RSSI is minus 95. Or if the gate is not longer visible. The test should be done using the type of S-gate that you use during the tracking. So if you have 5 types of S-gate, you can characterize 5 types of S-gate. Remember, we come with some already defined, and so typically you don't need. But we want just to show you that as a partner, you have the flexibility to prepare for special customer, special table. For each of this value, you can create a CSV table associated with the RSSI value, and the table consists of 3 columns: the ID, the distance, and the RSSI reference. When you have this, you are ready. You can the wizard will help you to download this CSV table. You have to push create a new and submit the configuration. The system will ask you to download this, and as you download, you can set up the device and say that all is okay. Click here, choose the file. These are on the documentation, step-by-step configuration that you have to do. Of course, now you can choose the CSV file from your file system, and when you confirm, the device is shown here and can be displayed. At this point, you have a complete configuration of your system. So now you are ready to go to see the map. Okay. To see the map, you can push tomorrow. We'll see, or today. I don't know if Paolo can show you something later at the end of my presentation, just to show you this site configuration aspect. So again, to modify a site, you can push again the site configuration. In this case, it's not starting the wizard, but it's starting to show the configuration, the basic configuration of the site. Suppose that you want to modify a floor, you can click on floor. you can create a new floor. So if you have one site and with master and then one floor, you have to define the layer. Again, remember that you have to take this layer from the RG's position. And if you select an existing site for the floor, you can click create, and you can create a new site. You receive the OK message, and now you are able to start with the system. Paolo, can you show something on the create? Okay, I leave for Paolo. If you have some question, I am available to answer. Paolo?
Okay, sharing my screen. Back. Okay, let's start again with the first time connection. This is our site. Maybe.
Mapping.
Just a moment. Okay, good. Starting. Let's try again. Okay, this is the Rajant Italia's the Reios site. Okay. I show you. Okay. This is the map. This is our map. This is our office. And okay, we talk about site configuration, so we can go to the configuration menu and go to the site configuration. In this case, the site configuration is already done, so you don't have a wizard at the login, but you just have a standard menu. But you can go back on the site configuration, accessing using this menu. Here, there is our map. Is Novara, Rajant Italia. I'll show you the map. The link is here. I can see that. As you go to the map viewer, because as yesterday Diego described, all the map are on the ArcGIS repository, so are on the ArcGIS cloud, and you can go to the map. Okay, by the way, this our network is, what is it? Okay, so this is the map that we have. Not yet.
Okay.
Okay. Take a while to refresh because of the internet connection we have. Okay, we're here in the Novara, in the north of Italy. In the north of Italy, come on. Okay, so this is the map, and the map information is one of the submenu inside the site configuration, the floor configuration. If you have a site with multiple floor, you can create a new floor, just adding a new layer. And for that layer, you will need a new map. The zero reference is instead written in this sub-menu. It is the site part of the site configuration, where you have to insert the latitude and the longitude coordination. Then we have for our site in Italy here our default template, and again you can recognize the Docker registry that we use for the provisioning of the devices, for the firmware of the devices. There is the Wi-Fi credential that we have in our office, and the MQTT broker, that is the local broker of our edge server. As you can see, the IP value is .16, and here I have a different value. As described before, this is the local IP address of the machine, and this is the VPN zero-tier access of the machine. But we are talking about the same server. In this case, again, you have a multiple profile. Let's suppose you have, for example, different floor. In each floor, you have a different Wi-Fi. So you can have the Wi-Fi floor 2, for example, here. And so that you can define different profile. And we will see tomorrow when we will talk about device configuration. When you configure a device, you have to select the profile that is that match with the device position. And the last submenu is related to the RSSI mapping table. By default, we have the standard indoor-outdoor reference table, but as Franco described before, you can create a new one using the create button. And I think that's all with the site configuration. Go back to the map. At the moment, the site is ready to add the gateway, and we will see tomorrow how to continue with the device configuration, and how to locate the device in a position inside the map, and then how to assign create area, badge group, and badges inside the map. We'll see also tomorrow the tracking the position of the badge, and also all the other functionality related to the authorized access of a badge in a specific area, alarms related to unauthorized access. We also have an emergency procedure in case of alarm, in order to notify and collect all the badge inside an emergency designed area. Okay, I think for today it's we have completed for the program for today. If you have any question,